Welcome Math 206 students. This is Dr. McGathy. We're working through a few examples using all the things that we've learned from section 11.3. First, we'll find the measure of each interior angle of a regular decagon. So remember what regular means? It means all angles are congruent. And also a decagon, there's that root word DEC as in decimal. This is a 10 gon. So you've got 10 sides, 10 angles. Okay, so for this one, we will be using that formula that we figured out for finding on the previous page, finding the measure of each interior angle for a regular n-gon. You do n minus 2 times 180 to find the sum of all the angle measures, and then divide by n to see how much each angle measure is. So what we'll do is we'll use this formula. Again, it's n minus 2 times 180, divide by n. In our case, n is 10. So 10 minus 2 is 8 times 180 degrees, and then we'll divide by n, which is 10. And what we end up with is 144 degrees. So if you have a 10-sided regular polygon, each angle measure will be 144 degrees. All right, so same types of information, but let's think of a problem from a different perspective. Find the number of sides, usually we call that n, of a regular polygon. Remember, all angles are congruent here. Each of whose interior angles has measure 175 degrees. So we're sort of going to be backwards engineering. We know the measure of each angle, and what we have to do is figure out how many sides there were. So in this case, it would be n. So let's start with that formula that we have, that we know each angle measure should be n minus 2 times 180 degrees, divide by n. And that should be the measure of each angle, and that is the information that I'm given. So I'll set it equal to that information, 175 degrees. All right, now this becomes an algebra problem. Let's multiply both sides by n to get rid of this fraction. We've got n minus 2 times 180 degrees equals 175 times n. All right, let's distribute to get rid of these parentheses. So we've got 180n minus 180 times 2, which is 360, equals 175n. Let's subtract 180n from each side so that I can consolidate all my variables to one side here. I've got negative 360 equals, what is this, negative 5n. Divide both sides by negative 5. And I have n equals 360 divided by 5, which is 72. This is a polygon with 72 sides. 72-sided polygon. It's hard to imagine. All right, let's do one more problem. This is probably the trickiest one, where we use the information that we discussed at the beginning of this section, having to do with parallel lines and how alternate interior angles and that sort of thing, which types of angles are congruent. Here, you're given that L and K are parallel lines, and you're given these two angle measures, angle here A and angle B. This is 60 degrees, that's 80 degrees. Can we figure out what angle X is? All right, so these two line segments here, AC and BC, they don't create one transversal. They actually each create their own transversal. So what I'm going to do is focus my attention here on the segment AC, and I'll imagine that being a segment of a longer transversal that cuts through these two parallel lines. So I'll call that transversal T. Because L and K are parallel, I know something about this angle right here. Let me label that angle. I'll call that angle Y. Angle Y and the 60-degree angle here, these are alternate interior angles. So I'll write that down by alternate interior angles. Angle Y there has measure, so the measure of angle Y is 60 degrees. All right, also, these three angles add up to 180 degrees. So I'll label this one angle Z, the one that's adjacent to X here. So I know that the measure of angle Z has to be 180 minus that 80-degree angle minus that 60-degree angle. So the measure of angle Z has got to be 40 degrees. And now because Z and X are supplementary, the measure of angle X has to be 180 minus the measure of angle Z. So that's 180 minus 40, or 140 degrees. And there we have it.